Hello, I'm Adam M., and this is my machine learning project for managing machine learning projects at Duke University. The project topic is helping retail grocery stores increase profitability and reduce waste by making more accurate inventory and purchasing decisions powered by an ML model. Currently, retail grocery stores face challenges managing inventory, leading to overstocking, spoilage, and reduced profitability. When the store does not have enough product through overstocking, it reduces store reliability, reduces sales, and decreases the customer base. So, how does ML solve that? Grocery stores have been collecting data through heuristic approaches for decades, such as historical sales, inventory, trends, holidays, and this could allow the model to use the data to create predictions that could help reduce waste, increase sales, enhance efficiency, and increase customer base. Currently, there's $11.9 trillion that the global retail grocery and food market is valued at. So there's so much money that impacts so many people's lives and their quality of life. So grocery stores, farmers, consumers, and regulating governments would be stakeholders in the project. The CRISP-DM business understanding, the target user would be retail grocery stores, and we'd be optimizing inventory levels and purchasing decisions for retail grocery stores to minimize stock issues, waste, and maximize profit. And it matters because incorrect decisions could cost billions in lost or produce or revenue and decrease the accessibility of food for people who really require it. And the current state is they're using a heuristic approach, which leads to human error, causing spoilage and stock issues. So for the success, we would expect our impact to decrease stock issues by a certain percentage, increase profitability, and potentially increase sales by a dollar value. So combining our metrics and our targets, our outcome metrics would be reducing spoilage and shrinkage by a percentage, increase customer satisfaction, increase profit, and the output metrics would be using an accuracy prediction like RMSE, as well as the percentage of stock and overstock rate. Our constraints would be products go bad and nature isn't always predictable, so sometimes farms run out, storage, and weather. We have some identifying factors, historical farming, things like that. So we would have to have um, a variety of things happening here. It would be a phased approach for our validation. The first phase, we'd look at historical backtesting and get a baseline comparison offline using the heuristics and the data we already have. Phase two, we'd launch the pilot and we'd have a shadow model going at the same time and we could determine the best performer. So this would be semi-online. And then phase three, would it be full-on A/B testing with the gradual rollout? We could use a champion challenger testing, which could all be online. So creating a model to predict forecasting inventory would use historical sales, farm supplier dates, external data like weather and traffic, promotional information to predict sales. This would allow multiple layers to work together, initially starting with the regression model and moving towards a more complex neural network. Looking at the ML design, we would need to offer a hybrid model as the ML model will grow in capacity, and it would start with a batch training strategy using historical data sets and developing a baseline. Moving through three phases mentioned above for the amount, we would move to a semi-online model offering could be close to a mini batch allowing for updates via streaming when available online to connect users, live updates, and that most likely would need to be a scheduled thing. The third phase would be a fully online, which would be via the cloud service with full integration across all the phases and across all the users. This strategy would be able to continuously improve, build trust with users, and lessen risk by validating in realistic environments as they change. So we are looking at some potential risks in production. So the data drift, there are changes in consumer behavior, demographic shifts, new products being added, and there's no historical data to retrain the model on that. So it'd be very similar with the concept drift, with seasonality, buyers' desires change as well as availability, and there would be no data to be able to train it on that. The training serve and skew due to every store and supplier keeping data a little bit differently. We'd have issues with time sensitivity and reporting because there could be subtle differences across the whole model, which would impact predictions. And latency at phase three, this would be a very complex model with huge amounts of data being added daily. This could be hard for the model to keep track and create, and this could create a slower response, increasing the latency. So ensuring we're using monitoring strategies to keep testing, tracking, and creating new solutions using this model. Thank you so much for listening. I really appreciate it.